This is going to be our lesson on inverse trig functions, but for the warm-up we're going to review just do a little bit of reviewing, and all of the review that we're going to do is going to be helpful in preparing us for the lesson, as well as just keeping things fresh in our mind for our test. So suppose a plane flies at an altitude. Remember the word altitude, I'm not sure if you noticed, means height, of 7 miles. So here we have an airplane flying at a height of 7 miles. So that's 7 is going to go. And it begins its descent 100 miles from an airport. So let's see. It's 100 miles. Here's the airport. And begins its descent. Find the angle of the path of descent. Now, the angle of descent is what we call the angle of depression. So it's this angle here on the outside. It's not this angle. If it was this angle, this would be the plane nosediving, going straight down, going from here to here. This is the angle of depression. Well, as you should have learned in geometry, alternate interior angles are the same. So the angle of depression is always the same as the angle of elevation. So if we're looking for this angle, we're actually looking for this one as far as which one's inside the triangle. So I'm going to use my highlighter again, and I'm going to highlight the different pieces. I've got, this is the angle that I want. These are the sides that I have. This is my hypotenuse. So these three have an opposite and adjacent. This is a tangent relationship. So tangent of the angle excuse me, is equal to opposite 7 over adjacent 100. So to find the angle, I'm going to take the inverse tangent of 7 over 100. And I'm going to put that into my calculator, and I will get an answer. So you're going to put an inverse tangent of 7 over 100, and then you'll get your answer for the angle. You're going to notice it's a very small angle, which it should be. A plane doesn't make a real drastic, a big drastic angle. Otherwise, it wouldn't be a nice, smooth landing. Okay. All right, number 2 asks us to sketch each trig parent function over the domain. So we're supposed to, these are just our basic ones. This is giving us a chance to practice them again. Remember, we always say pi and 2 pi. Put that in half. And cosine. Put the little half marks in. I'm not going to write all of those in. This would be pi over 2, and this would be 3 pi over 2, and those are my 4 corners. Same thing here, these are my 4 corners going the other direction. Cosine, I know, starts up, and it forms that U. And there's the other direction. And makes my other U. Then I have sine. I'm going to set up my graph the same way. And I'll put the little hash marks in to show the pi over 2 and the 3 pi over 2. I'm only not writing it in because I have kind of a small space here, and it would just get very messy looking. And sine begins at the origin, goes up, and comes back down. So there's sine, and then I've got tangent. Every time I set up my graph the same way. For tangent, I remember that my asymptotes are at my pi over 2's. And I have my curves that cut through on the x-axis right in the middle there. Are these functions? Well, I would say yes, because they pass the vertical line test. I'm going to write I guess I'll write it out. Vertical line test. Will their inverses be functions? Well, in order to determine if their inverses will be functions, we learned back, I think it was in our first unit, we talked about we could do a horizontal line test in order to make a prediction about the inverse. So, because the inverse, we do the vertical line test to see if the actual graph is a function. If we want to make a prediction about the inverse to determine if the inverse will be a function, do the horizontal line test on the original. Not on the inverse, on the original. We're making a prediction about the inverse. Well, if I look here, my pencil, well, it definitely doesn't pass the horizontal line test. It hits lots of places. Same with sine, same with tangent. So the answer is no. It fails the horizontal line test. So the inverse will not be a function. Now, you might be wondering, okay, so the inverse isn't a function, that's fine. But that isn't fine, because the thing that we like about functions is that when you put something into a function, you know that there's only one answer that can come out. It's a little unsettling that if with inverse cosine, inverse sine, and inverse tangent, if we put something in, we might not all get the same answer that comes out. That is unsettling. How are we going to know what the right answer is? Well, I want to show you something. I need you to have your calculator out. We're going to run a little experiment here. And we're going to see if indeed the inverse is not a function, and if it somehow seems like it is, how did that happen? Because it obviously, if you do the horizontal line test, inverse cosine, inverse sine, and inverse tangent are not functions. There's no denying it. It fails the horizontal line test. So I want us to try something. I want everybody, make sure your calculator mode is in degrees. That's key. And I want you to do inverse sine. So we're going to do second sine. And we know that sine has to be somewhere between -1 and +1. So let's do 0.7864. And I got 51.85 degrees. And what I need you to do is look at your calculator and see what you got. You should have gotten the same thing as me. We all got the same thing. Which makes me think, well, somehow it's a function, because why didn't we get all different answers? Let's try inverse cosine. Inverse cosine. Let's do the same one. 0.7864. 38.15. Huh. Did you get 38.15? Let's go to second tan. Now, tangent can be any number. So let's do, I don't know, 9.6. 84.05 degrees. Did you get 84.05? For some reason, even though inverses, as evidenced by these graphs, should not be functions, it appears that they are because we're all getting the same thing. The reason that we're all getting the same thing is what mathematicians decided was that, okay, as a whole, the inverse would not be a function. So what we're going to do is we're going to take one piece of the original, and that one piece has to have all the values from the unit circle for cosine, all the positive values and all the negative values. And we want that one piece to be a continuous piece. So if you think about my unit circle and you think about cosine, the cosine of the unit circle, okay, this is going to be positive here, then it's going to be negative here, and positive here. We want a continuous piece of the unit circle, and we do want to always start here. We want to somehow include this, a continuous piece that would have all of my answers. Well, here would be my positives, and here would be my negatives, which would be this part right here on my graph. If I look at just this piece of cosine, I will have all my cosine values, all of them, and they just repeat down here. All of my cosine values will be here. And if you did the vertical line test, the horizontal line test on just this yellow piece, it passes the horizontal line test if the yellow is the only piece, which means my restricted domain, what we're going to do is we're going to jump down to this table here. My restricted domain for cosine of x, in order for the inverse to be a function, is going to be from 0 to pi. Okay? All right. Now, let's go to our next one. Let's go to sine. On my sine graph, let's look at my unit circle. Sine is positive, positive, negative, negative. Well, positive, 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 negative. On this side is the first time I run into it, but I want to include this point here. So I'm going to go from here to here. Now this might seem like it's not a continuous piece because we're here, we jump over, and then we're here. So we have to define this piece here, which is quadrants 1 and quadrant 4, here, like this. That's the piece on sine. What we're going to do, and this is what throws people off, is rather than thinking of my normal part of the unit circle that says pi over 6, pi over 4, pi over 3, we're still going to have that up here, but down here, rather than 11 pi over 6 and 7 pi over 4 and 5 pi over 3, we're going to call it negative pi over 6 and negative pi over 4 and negative pi over 3. So we're going to go from negative pi over 2 to pi over 2. Oh, I'm sorry, you can't see what I'm writing there. My apologies. All right, and the last one, tangent. Think about tangent. Tangent is positive, negative, positive, negative. But we have an asymptote here, which makes this not continuous. So we want this piece, just like we had for sine, for the inverse. So we are going to look at negative pi over 2 to pi over 2.